Hello mathematicians, I hope by the end of this video and with a little bit of practice you can say I can use data from a random sample to draw inferences about a population with an unknown characteristic of interest. So we're going to be mainly working on interpreting box plots right here, okay? So it says the box and whisker plot below represents some data set. What is the value of the median? Well, we know the median is just this number right here. So our median is going to be right here, and I guess our question now is what are they counting by? They go from 100 to 150 in 1, 2, 3, 4, 5 steps. Okay, so each one of these little tick marks is going to be worth 10. So it's going to go to 100 to 110, 120, 130, 140, and 150. So this value right here is 110. That is going to be our median. So now it's asking for the value of the lower quartile. And that's easy because it's just given to us right here. The lower quartile is going to be right at 62. And now it's asking for the upper quartile. So the Q3 or the upper quartile is right here. Now I guess our question is what are they counting by? It goes from 60 to 80, so that's a difference of 20 in 1, 2, 3, 4 steps. So that means that each one's going to be worth 5. You take the difference between the two, so from 60 to 80 is a difference of 20, and you divide that by 4 because there's 4 tick marks between them. Okay, so that would give us 5 for each one. So we'll go from 60 to 65, 70, 75, 80. So this upper quartile is at 75. So our minimum right here, way on the left over here. So it goes from 0 to 20. So a difference of 20, obviously. And 1, 2, 3, 4, 5 tick marks between it. So 20 divided by 5, that's going to give us 4. So each one of these tick marks is worth 4. So it was 0, 4, 8, 12, 16, 20. So this is right at 8 right here. So that would be our, we're looking for our maximum. Okay, well, it's still counting by 4. Well, I guess our minimum would be 8. But anyways, it's asking for our maximum. So my mistake there. But anyways, it's still, that'd be 64 because it's still counting by 4. So it goes from 60 to 64 would be our maximum. So now it's asking for the range of the data. Okay, so it's not specifically given to us, the maximum isn't, but it goes from 150 to 200, so a difference of 50 in 1, 2, 3, 4, 5 steps. So 50 divided by 5 is 10, so each tick mark is worth 10. So 150, 160, 170, 180, and 190. So our max is 190 minus our minimum of 50. So 190 minus 50 is going to give us 140. So that would be our range. So now we're getting into maybe the more difficult part of interpreting box plots. We're looking for, it asks us what percentage of the data values are between 20 and 76. So 20 is our Q1 or our lower quartile, and it looks like 76 is our upper quartile. So we know that what the minimum and the Q1, there's 25% of the data between here, and there's another 25% from the lower quartile to the median. Also, the median is also technically known as the second quartile. Another 25% from the median and the upper quartile, and another 25% between the upper quartile and the maximum. So we know that there's 25% from here to here, and 25% from here to here. So that is the range it asked for us. So there is going to be 50% between 20 and 76. So now it asks what percentage of data values are less than 180. So 180 is our maximum. So there's a 100% is less than 180. Now it asks what percent of the data values are greater than 24. It looks like 24 is our Q1 or our lower quartile. So there's going to be 25% from here to here, 25% from here to here, and 25% from here to here. So 25 times 3 is going to give us 75%. So now it asks us what percentage of the data values are greater than 60. 60 is our Q3. So that is going to mean that only 25% of data values are greater than 60 in this data set. So that is it on our video. I hope by now, with a little bit of practice, you can say I can use data from a random sample to draw inferences about a population with an unknown characteristic of interest, specifically analyzing box plots.